1. Right? Q0, Q1, you need to combine these two, input A, so you have 0, 1, 2 here. It's 2, huh?
你再听。
Actually, there is a comma in between. You write comma, I don't have space. You just put a comma in between each of the steps. 0, 1, 2, and then this one is
这
a
两个
0,
谈第几
2.
题？今天的第一题。今天刚刚之前就讨论了10分钟。
0, 2.
嗯。
So now you already have 0, 1, then now here you have 0, 2. That means the next step you will go to Q0, Q2. So you look at these 0 and 2, combine them, so you get 0, 1, 3. So here is 0, 1, 3. For B also the same, combine the 0 and 2, so we will get Q0 only. Then once you already have a 0, 2, that means next one, which one we should write? Which one? After 0, 2? 0, 1, 2. Right, follow this, huh? So 0, 1, 2, combine these 3. So we get 0, 1, 2, 3. And for B, we have 0 and 2. Okay? We already have 0, 1, 2, so the next one will be 0, 1, 3. Zero, 1, 3. So we will get 0, 1, 2, 3. And for B, 0, 1, 3, we have 0, 2, 3. So 0, 2 done, 0, 1, 2, 0, 1, 2 done. We need to go to 0, 1. This one 0, 1, 3 done. So we have 0, 2, 3 now. Okay, 0, 2, 3, 0, 1, 3. And for B, 0, 1, 0, 2, 3, we have 0, 2, 3, 0, 1. 0, 2, 3. This one and this one. 0, 3. Right? 0, 2, 3. Yeah? So you have 0 and 3. For 0, 2, 3. 0, 3. So after 0, 2, 3, we go to what else? 0, 3 first. 0, 3, we have 0, 1, 3. What else? 0, 1, 2, 3. So combine all, you also get 0, 1, 2, 3. No, not in. already, right? So you will get this as a deterministic now. Do you know how to get this? Put A and B. Can you add in all the brackets? Here. One step. Put all in one bracket. Okay, you don't follow like me, This one all you add in the bracket. All add the bracket. 你是的吧? You add yourself all the brackets. You must write bracket, If not, later when you do, you will ignore the bracket, then it is wrong already. You must have the bracket for deterministic finite state machine. Okay? I told you already, if you don't put a bracket, that means you are not listening. So this one you add in one by one. Or every step also add in the bracket. Like this. All add in. So if the question is a non-deterministic, you need to determine how to convert to the deterministic, follow the step like this. And if the question asks how to write the LM, then you need to think of how to start from the Q0 until the Q3. In this case, it is the acceptance step for this case, Q3. So every time when we write the LM, it must be start from the starting step, Q0, until the acceptance step, which is Q3. So you need to think of all the possible way to go from Q0 to Q3 in your LM. Okay? So look at this example. How do we want to write for the LM? How to reach from Q0 until the Q3? Can write LM. You give me the answer. If I want to start from Q0, and then I go, stop at Q3, what should be the LM? Start from what? This one can be a loop, right? So if this is a loop, we should put A or B and then loop, isn't it? The A or B is in a bracket, meaning that you choose one only to loop every time. Every time you loop, you choose one. Okay? Then you go to Q1. Q1 you must have A. Then when you go to Q2, you can choose again either A or B. Right? So here is A or B. After you go to Q2, then at the Q2 to go to Q3, you only have one choice, which is A. And at the Q3 here, you can look again, A or B. Look. This one is straightforward. Okay? For some of the question, there are many possibility. Then that one you need to think properly. So the assignment that will be released later on after the class will be covered until this chapter. Okay? And you try to... The deadline is next Monday by 2 p.m. So you discuss with your tutor how to submit your assignment to your tutor. Okay? Any question for this chapter? No? No question, I go to chapter 5. The extra question you can try. This one, the extra example. Same method also, like our example, the previous one. This is the deterministic one. And this one also the same. This one is initial is 0. Okay, so this one is accept or not. It's just see whether it can reach to the acceptance state or not. Okay, remember to put a bracket if it is a non-deterministic to deterministic. You need to put this curly bracket. And if they ask you to draw the diagram, then you need to put a circle. For the state that is the acceptance state, for example Q3, this is the acceptance state. So whenever inside here you have the Q3, you need to draw with a circle. As long as there is a Q3 inside the state, then you need to put a double circle, which is acceptance state, when you draw. Okay? So, put a bracket and a double circle for acceptance state. Okay? Now, we go to chapter 5. Coding theory. So for this chapter here, for the chapter 5, the coding theory, we need to understand first some of the terms. Now let's say this one is regarding the message that we send day by day from one to another. So when we send a message, normally they will say there is a disturbance, or we call it as noises. So when they send, normally we will use a binary code, which is 0 and 1 for the device. Okay, and then from the string that we have, normally if they send from one to another, if there is some disturbance in between, that means the message sent will be an error happen halfway. Okay? So if there is an error happen, that means the person who sent the message and the person who received the message will be different. Right? So in that case, the code that we send and the code we receive, we will say that we encode from how many bits to how many bits. So the bits will be the power here. Let's say it is the m bits, and the person who received is n bits. Now, what do we mean by this encode? Means that now you send a message. Let's say I send with a 3 bits message, which is a 101. This is a string, but normally the message will convert to word after they reach the acceptance state, isn't it? So same also for this one, we will represent the message in a binary code first. So here, 101, the person who sent, and the person who received is 1010. That means the length here is from 3 bits to 4 bits. You send with 3 bits, the person who receives the message will have 4 bits. So why this happen is because we need to know whether there is an error happen or not. So we can say that this extra bit is actually for the checking purpose or for us to detect whether there is an error or not. Okay? So here there will always be n more than m. The length of the n here, for those who receive the message, the code will always greater than the person who sent the message. Okay, so just like this, 3 to 4 bits. This number is representing the number of bits. Okay, now how to do the detecting of the error? We have one method which we call it as the even parity check code. Even parity check code means that we will check the code whether there is an error or not by following the weight of the code that we have. For example, if the word is B1, B2, B3 until Bn. Okay, let's say the word we send is this. The string is until the n bits. So when you encode, right, the encoding here, it will become B1, B2, B3 until Bn, and they have the extra bit at the back here, which is a Bn plus 1. After the n, it will become n plus 1. So what is the last bit here? If we follow the even parity check code, they say that the number of 1 in the code that we have here is always even number. Meaning that it will be like this. The EW here, which the last bit, Bn plus 1, will be 2 possibility. Either it is a 0 or it is a 1. Right? So when we will get 0 for this last bit here is when the weight of the original code, this one, the original code, the number of 1 is even. If the number of 1 inside the original word is even, then the last bit we will just put it as a 0. But if the last bit of this is 1, that means the original code will be odd number of 1. Okay? Now, this can be explained by the simple example. Let's say I have a code of 1, 1, 0, 0. Let's say this is the W. 1, 1, 0, 0. So from the W here, I have 2, 1, isn't it? 2, 1 means the weight. We call this as the weight. How many 1 is the weight? How many 1 here? What is the weight of this code? Then you say 2. Okay, you just see how many 1 in the code given. If 2, 1, then the weight is 2. So for this one, the modulus here is referring to the weight. What is the weight of this W? 2, right? So 2 is even, isn't it? That means when I encode this one, follow the even parity check code, the last bit here, I should add in 0 or 1. What should be the last bit? 0, yes. So always follow the even parity check code, meaning that the weight of the code that we have is always be 1. Then it will be considered as the correct code. Okay? Now, if let's say the W now is 1, 1, 0, 1, then what will be your parity bit? Parity bit means the last bit here. So what is the parity bit now? 1. Why we put 1? Because the original here is 3, 1, isn't it? 3 is odd number. But in the parity check code, it will always be even. So in order to make the code here becomes even number, the last bit here must be 1. Correct not? Okay. So by using this even parity check code, we will know that whether there is any error happen or not. Because if let's say you receive a word with odd number of 1, then you will know that there is error happen in between. If we follow even parity check code. Okay? We follow the even parity check code, it will always be even number for the correct code. If your code you receive is odd number, then we can detect there is an error. Which one is the error? We don't know. We only know we can detect the error only. We don't know which one is wrong. Okay not? So this one we only do for even parity check code. Of course there is odd parity check code also, but we don't do the odd parity check code. Okay? Now, here is the explanation of how many errors we can detect. Now next one we look at the distance between two codes. Okay, let's say I give you the first code x. The code is 100101. Second code I give you y 011111. When we want to find the distance in between the two codes, the distance you see the modulus here, we need to use the exclusive OR. Still remember exclusive OR how to do? In your chapter 3, you already learned in the semi-group and group how to do the exclusive OR. What is the answer here? 1 is 1 1 0 0 1 1 0 1 1. This one I give the distance 3 because I use different example. If you want to get the same answer, then change this to 0. Okay? We use a different example, so you get a different answer. So now, if you use this example, you will get 0, 1, 0, 1, 1, 0. That means the answer here is x exclusive or y. You get how many 1 in your answer? 3, right? So the distance in between the x and y now is 3. For the sum? For the same is 0. Exclusive or? Is 0, right? Correct? Okay. So for exclusive OR, we will only get 1 if 1 is 0, 1 is 1. If both 1 or both 0, we get 0. Okay? So the distance is 3. So next time when I ask you to find distance, you know how to find, right? Just use exclusive OR for the code and get the distance. This is a theorem for the distance. The distance, we can use the delta to represent it. So the distance in between x and y, of course, will be the same with y and x. It will be greater or equal to 0. And then if the two codes are the same, then of course the distance will be 0. Right? And this one is xz, the distance, and the zy. If you add up together, it will be more than or equal to the distance between x and y. Okay, this is among the two chords. Okay, now we want to find for the encoding function, how do we want to find the minimum distance? So let's say you have this. This one we call it as encoding function because we send a message from 2 to 5. See how to read this one, the bracket here? 2, 5 means what? 2, 5 means you encode from 2 bits, which is this, in the bracket 2 bits. 5 means the person who received the message will be in 5 bits. So we will say that it is encoded from 2 bits to 5 bits. So sometimes they will just write it in a bracket as 2, 5. Understand? Okay. Now, if they give you the encoding is like this: 1, 2, 3, and 4. You have 4 pairs here, and they want you to find the distance between all the pairs of the code words. Meaning that we need to know what is the distance among these 5, 0, and the second pair, first pair, and the third pair, first pair, and the fourth pair, and so on. Among each of them, what are the distance? So, in order to do one by one, it is easier you put it in a table form like this, and you write out all the 4 codes, okay, column and rows. 4 rows, 4 columns, write out all the code, and do the exclusive OR. One by one. Now, this one will be the diagonal. You know the diagonal, right? You know what is diagonal? This is a diagonal. So, whatever above the diagonal or below the diagonal, the answer will be the same. So you no need to fill in all the cells here. What you need to do is you just do either above the diagonal or below the diagonal. Either you do the upper triangle or you do the lower triangle. The answer are the same. So don't waste your time to do all that. Okay? Do I do the above one. So you have 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, and this is 1, 1, 1, 1, 1, right? Then this one is C1. I write here also. This is C0. Better we use C to represent it. C1, C2, and C3. So now C1 and C2, what do we get? 0, 1, 0, 0, 1, right? C1 and C3, what do we get? 1, 0, 0, 0, 1. Correct? You can do or not? Then C2 and C3, what is the answer? C2 and C3? Okay. Now, when they ask you the minimum distance, so you see from here, which one is the minimum? Not 0, 1, the minimum distance not equal to 0. So which one is minimum? What is the minimum distance? What is the distance for this? This one is 3. 3, 5, 2, 2, 2, right? So minimum distance is 2. minimum distance is 2, it means that we can detect how many error. Now, if we follow the theorem just now, it says that if the minimum distance is k, then we can detect k minus 1 error. So in this case, if the minimum distance is 2, meaning that we can detect 2 minus 1 error, which is 1 error. So we can detect 1 error in this case. Okay, done? So here is the theorem. They say that the encoding function can detect k or fewer errors if the minimum distance is at least k plus 1. So that means if your minimum distance now is 2, that means we can detect 1 error only. If your minimum distance is 3, then your k plus 1 equal to 3. That means your k here will be equal to 2, right? K plus 1 is 3, k will be equal to 2. Correct or not? Okay. Now the next one we will look at is the group code. How do we want to prove that the code given to us is a group code? So again, under this group code, it is actually the same with the subgroup. I hope you still remember how to prove a subgroup. How many conditions to prove a subgroup? How many conditions?
3.
3. Yes, we have 3 conditions to prove a subgroup. So here, in order to determine the code given is a group code or not, we need to make sure that all the code form a subgroup first. Okay? So here we have the example. Let's say we have C2 and C3 from the previous example. What do we get from these two? If I take C2 exclusive of C3, I will get 0, 0, 1, 1, 1 exclusive of 1, 1, 1, 1, 1. What should we get? We get 1, 1, 0, 0, 0, right? Now, because of C2 and C3 are in the range of the E just now, so what we will write is, because C2 and C3 is belongs to the range of E, the E means code given. Just now you have this, right? Look at this. C0, C1, C2, C3, right? So we put this one as C0, C1, C2, C3. Now, if let's say you take these two, C2 and C3, right? You exclusive or you get what? You get this one. These 4 are the code given. If it is a subgroup, that means any of the code here, when you exclusive all this, inside the table, the answer you get, it must be from this 4 code also. If it is a subgroup, right? It must be closure, right? That is a condition of a subgroup. But now what do you get? You see here is 1, 1, 0, 0, 0. Is it belong to one of these? No. So that means the first condition to show that it is a closure under the code here is not true, right? So we can conclude that it is not a group code because it is not a subgroup. So now C2 and C3 belong to the range E. The range E means the C0 to C3 . Then after we do the C2 exclusive or C3, we get that it is not belongs to range of the E. So we can conclude that these four codes are not the, it's not a subgroup, of B5. Why we write B5? Because they have 5 bits. Since it is not a subgroup of B5, then we can say that the encoding function is not a group code. So if it is a group code, you must show it is a subgroup first.
还是我们做6题然后一起选？
也可以啊，但是我个人目前没有这样子看2题啊，
你
有6题啊，但是我会做完6题啊。
让我看一下我做完6题。
改一天。
OK。
Not sure that it is a subgroup. Now you understand this? You understand? Okay. Now, if this is not a subgroup, right? Then how about this? C0 to C3 are given like this. And the question here asks you to show that the C is a subgroup of B5. Now, remember that as long as the question asks you to show that it is a group code, you need to show that it is a subgroup first. How to show? Using this one. So you must show that it is a subgroup of B5 first. Then only you can conclude that the encoding function is a group code. Okay? If it is not a subgroup, then it cannot be a group code. So if the question asks for subgroup and group code, actually the same thing you need to do. You also need to show that they are subgroup first. Like this one, they only ask to show that it is a subgroup. So you don't need to conclude whether it is a group code or not. You know what? Okay. So now for this example, to show that it is a subgroup, that means it must be crossed under all the 4 codes here. Then you can put it in a table, easier to see. Put in a table form, like just now. 4 codes, follow the label here. C0, C1, C2, and C3. The row also the same, put the 4 codes. This one is 1. Okay, here exclusive of. Okay, you fill in this one. Try to fill in the table. I write the diagonal for you. So either you want to do the upper triangle or lower triangle, no problem. Up to you. Okay, fill in first. C3. And 1. So you can see that this is from C1, C2, and C3, right? Then this is included under this 4. Then the C1 to C2 đấy.
Nó không hóa đây. Đây
1,
là
1, 1.
cái phát đấy. Ấy kia là gì? Đấy cái chưa.
1, 1, right? C1 and C3. 1, 0, 0, 1, 1. C2 and C3. 0, 1, 1, 0, 0. Right? Okay. Then you have all the code which is belongs to C0 to C3 inside the table. This one you can write if you want to confirm they are the same. This is a C1, this is C2, this is C3, C3, C2, and C1. Okay. Now this is actually to show that it is a subgroup of D5. And the first condition, now we have 3 conditions. You need to write out all the conditions after you show this table. Not only show like this. You need to write Ci, Cj belongs to C. Meaning that the I is a row, the J is a column. So what is the I and J? I is from 0, 1, 2, 3. J also 0, 1, 2, 3. Row and columns. All the Ci and Cj are belongs to the 4 codes here. And then after we do the exclusive OR for Ci and Cj, we also get all the answer here belongs to C. Agree? All these you see? 1, 2, 3, 3, 2, 1, all from the codes, this form. Right? So we will need to write like this to show that it is a closure. Okay? Close under this exclusive OR. So Ci and Cj also belongs to C. This is the first condition. Now, for a subgroup, the second condition, what should we find? When you do the subgroup, what is the second condition you want to prove? What do you want to find? After the clause under the exclusive OR, this is the first condition. Second condition, what do you find? Subgroup. Nobody know. First one, it is crossed under the exclusive OR. Second one, what should you find? The condition? Find what? Subgroup. Have you done your tutorial already? Tutorial 4. Finish already. The semi-group and group tutorial, have you done? Have you done? Hey, class, are you here? Semi-group and group tutorial, have you finished? Finish? No. Okay. So the next one we find the identity. What is the identity here? Which one is identity? Zero. Okay, C0 exclusive OR the identity. You get back C0. C1 exclusive OR identity. You get back C1. C2 exclusive OR identity. You get back C2. C3 exclusive OR identity. You get back C3. What is the identity? C0, right? Correct? Okay. So identity equal to all 0, which is equal to C0, and it is belong to C. You need to make sure it is inside the code given also. Okay? All 0 is belongs to C. Second condition. Now the third condition is to find the inverse. So C0 exclusive or the inverse, you get back identity. So that's why you need to find the identity first. Huh? C1 exclusive or C1 inverse. You also get back identity. C2 exclusive or the inverse. What is a C0 inverse? What is the inverse here? To get this? Same or not? Same. C1 inverse. C1 is this, 0, 1, 1, 0, 0. C2 inverse. C3 inverse. Okay? So we get all the inverse identity belongs to C. So this one is subgroup of defined. So the question asks you to show that the C is a subgroup of defined. So we have shown that the three conditions.